Thank you for the kind invitation and introduction. Ladies and gentlemen, I'd like to talk today about safety risk assessments for all operators. What could you do? Heinz has explained the challenging aspects of the ARIAS project and the procedures we like to and have already set up. Some of them, the approval is pending for the described and mentioned reasons. I would like to share what we learned from the safety risk assessments and how you could do that also for your operation. And I would like to take the liberty to talk to you in the next 27 minutes about that. So first of all, that was already mentioned, safety risk assessments for all operators. There are no conflicts of interest I have to declare. Affiliations are depicted, but I think also quite well known, so I can skip a little bit time. And the question is, why do we talk about that? What is so important? Why does the gentleman stand here and talk to us? Well, risks are always inherent factors, and you have to manage them. I know, it might be, you could consider that as water under the bridge. But I would like still, or nonetheless, talk to you about that, because hazards might lead even to risks, and they might cause crises. And these crises, or you could call them also critical situations, have to be identified early and, well, dealt and de-escalated. Because if you don't do that, you end up maybe, or sometimes certainly, in a disaster. So crises have, on the other side, also a positive potential for organizations for an improvement. We can learn from that, and that is why it's so important to talk about risk assessment and risk management. So the definition of a risk. That's nice mathematics. It's too late for mathematics, I know now. It's not early in the morning, nobody likes to read that. After all, we can look at the definition. It's a sum of different stages and probabilities. And I will talk about this sum in pragmatic words, I hope at least. If not, you can blame me later for that, please. So, from hazards and risks. When people sometimes talk about hazards and risk, they mix it up. And I'd like to try a definition. A hazard is a potential harm, whereas the risk is an adjusted hazard that might happen to realize. So it's time dependent. So I have to also, that is what my teacher usually would do, it's from hazards to risks. So you have a hazard, and it depends. If you have a certain exposure, you get the risk. And that is the definition I like to work with. And when we talk about that, the probability, and that is the important aspect, and severity have to be, well, analyzed, guessed, estimated, or known already. And there are some definitions you might want to consider, but for your operation, of course, this is nothing carved in stone. So feel free, of course, to negotiate or talk it over with your authority and adapt it to your operational needs. And on the other side, we have also to look at the outcome. What is the severity of a situation? Is it neglectable just? Well, it happens, so what? Is it minor, unpleasant, major, even hazardous or catastrophic? When we analyze the procedures, and the most important aspect is always what will be the catastrophic. Most important thing is what I like to show with you and talk with you. So we talk about a near mid-air collision, a CFIT, or even a mid-air collision. That these are things, among others, loss of control that end in catastrophic situations. And in your chart, in your risk assessment chart after that, which is usually also part of your OMM, you end up with a certain values. So, what is it? Risk and error trajectory I'd like to start with. First of all, nothing happens all of a sudden. So we start with a regular operation. Let's call it state 0. That's what usually should happen. Then you might have some unfavorable circumstances, and you end up in an operation with a hazard precursor, state 1. Now, maybe technical failures and human error happen, lapses, or maybe also errors after gross negligence could also happen. All of a sudden you operate in a degraded condition. And if you don't do anything, if you say, okay, well, it will happen, but not to me, you end up in an incident, or if we talk about the catastrophic aspects, you end up in an accident. So this is one part, one way of looking at it. If you have an escalation to that extent, there is also a de-escalation, of course, and that is what we have to see as well, because that is something what we have to learn in order to implement that for our operation, because we would like to avoid that in the future. So how does that go? Usually we have likelihoods where we usually then the likelihood from coming from the regular operation to the operation with the hazard precursor is the likelihood P for likelihood probability 1. You have then from this again and to S3 also likelihoods. Same way back. Why is that dotted? If you have an accident, it's difficult. If it's a real severe accident, to come back to state 2. That is not always the case. Then again, of course, it would be too easy if we do it just this way. There might be also, you might jump and skip one or the other state. Or you might skip all the stages. This one, for instance, if you look at the red dot, that is, for instance, something when we talk about flying in inadvertent entry into instrument meteorological condition, double IMC. All of a sudden, you end up in an accident. We learned that from the analysis also in EHEST, and also Helicopter Association International has recently published that you have approximately 30 to 60, or I think they said 54 seconds until you crash. So you end up here without the previous. That's what you might think. You could even say if there are clouds, if you fly towards clouds, you have that already, you should see and act. Same here, you could also skip with respective actions back to the escalated stage. So that is very theoretical, but I like to do it that way for the time being. I come to practical examples as well. So important are also the corrective actions and de-escalation, and maybe you find also some favorable circumstances that improve the situation again. After all, you might have heard it, you end up with a Markov Matrix. So what you've seen, the likelihoods here in the matrix, these should be always 1, because the likelihood of all probabilities is 1, because then it happens. When you get back, I do that, you could say, well, not every time you end up at an accident. Absolutely right. If you have, for instance, S0 or S1, you could have several likelihoods that you stay within S1. This is what you see here, probability 1, 1. So you stay in 1, from 1 to 1. This is the probability from 1 to stage 2. Probability from 0 to stage 3. So, and that you see, all the columns here should be 1, and that is what the formula means. This is in a nutshell. Markov matrix, important because the likelihood that something happens altogether is always 1. Oh, I promised you and tantalized you already a lot with mathematics. I'm going to do that not again. Okay. We look at that pragmatic now. Stage 1, the helicopter operates in IFR. That's what we do in this case. In IMC, okay, that's why we fly IFR, and approach pins without ATC. That's what we do in a low flight network at some procedures. Then the hazard precursor is we get a TAS alert, for instance, of other VFR operating helicopter without a visual contact. Yeah, if you're in the clouds, it's sometimes difficult. That's the reason why we fly IFR. But still, we get an alert. Now, the other helicopter does not change course or take any evasive action. Now, if you say, it won't happen to me, don't worry, he will see me, the MAC or near MAC is quite likely. This is something what we avoid, of course. When we estimate the risk, we come to the likelihood of this situation from stage 0 to 1, 10 to the minus 3. We estimate it for 1 to 2, 10 to the minus 2. It's a human factor. Usually we calculate human factors 10 to the minus 2. And finally, if nothing happens, how often will that happen? It's 10 to the minus 3, what we estimated. So why is that? How does the guy come to this conclusion? How do you come to these numbers? Well, we have barriers, natural barriers in our operation therein. We have TCAS, floors, VHF area. We do blind calls also. And our AIP is also published. We have a flight plan, and we have, of course, a transponder with a code. And then, if we are still here, we have in the operation concept the SOP. If there is any other traffic closer to 1 nautical mile or 500 feet, we do a go-around. And we apply, of course, the see and avoid in VFR. So that is the reason why we end up with these likelihoods. So after all, the likelihood to end up in an accident here is 10 to the minus 8. Who is going to do that? Who should be involved in such an estimation of the risks? Well, you need people from all parts that are involved in the operation, but also behind. That means operational experts, pilots, crew members. Don't forget the other airspace users. If you have gliders, for instance, talk to the glider associations, sailplane, whatever it might be. When it comes to operation with helicopters, like we do here with the ANPAR procedures, we need also experts from the OEM, because we talk about an aircraft and all the subsystems. You need company SMS experts, infrastructure experts, because you need to know where you land and where the operation takes place. But also, as infrastructure, air traffic controller, and of course, procedure designer. That are the people. And these people need to have a knowledge of the operational circumstances, need to know what SMS means, the local situation, understand this safety risk assessment process, and very, very important, they have to have an unbiased attitude. It's not the go mentality. It's not that we look for the people and say, yes, go, you can do. Well, no worries, you're great, just do it. No, we would like to know what can go wrong. And if moderating such a session, the question is always, what do you expect? What do you think, how likely is it that there will be a helicopter approaching us, or will be also in the air, we get such an alert? How does that work? How often does that happen? And that is the process. So first, we do the hazard identification, then the hazard classification, and then mitigation. I get into that now. You know that already. Now let's look at it. What does it mean when we do the hazard identification? When the hazard identification, I'm not interested at that moment in the likelihood, so we skip that. I'm interested in naming that. You know already these ones. Now I listed here another one. Maybe the experts say, okay, the helicopter operates in IFR and IMC. Okay, no, that's what we want. There might be a wrong QNH entered. Okay, then I ask, what is the consequence? Yeah, well, it's a lack of situational awareness. And what could that lead to? What do you think? Why do you name that? Well, a CFIT. Okay. And you continue asking, what else could happen? What could happen? Don't ask how likely it is. Let the people talk. Document it. Somebody has to document all that, because it's priceless. And then, after that, after you have completed that, you start the hazard classification. Here we go. Then we start, okay, how likely is it that there will be a TAS alert of other aircraft? And then the experts will say, well, we think it's 10 to the minus 3. Or they say improbable or likely, frequent, according to the definition. I tend to use these formulas, 1 in 1,000 flights. And now it's a question, do we use flights? Do we use flight hours? Do we use missions? Define that, that's important. It depends also on the hazard and risk analysis you do. And then we have also to ask, why do you think is it 10 to the minus 2? Why do you think it's 10 to the minus 3 here? And also these natural barriers that already exist have to be documented. So first, you have the hazard identification, and that could take, for some safety risk assessments, maybe half a day, maybe 1 day. It depends on the complexity. And the second one is the classification, where you end up then with a likelihood, a probability of 10 to the minus 3 in this case. Mitigation. Whenever you have a likelihood that is greater as your target level of safety or considered unacceptable, you have to find for additional mitigation measures. So you do a mitigation identification, existing barriers versus and new barriers. So you identify mitigation possibilities. And then, also important, classify them. How likely is it that the mitigation will work? Because that has to be also combined in the overall likelihood, because it's a mitigation factor. And if it's always the case, you say that works in 100%, you can say 1. If not, it's maybe 70, 80, 90%, but has to be classified. All that we usually enter in a hazard database. The columns for that we use usually is the number, so we can really, every hazard has its own number. Description, we have the different likelihoods when we change the stages, the severity, mitigation, liability, severity after the mitigation, that is what you're interested. Maybe you have, before you have catastrophic, and then you end up in neglectable or minor. Very important, responsible expert for the specific hazard. He has to deal with that. And last and next evaluation. Then we also work with a master minimum hazard list. These are the hazards that we consider as so important that we would like to look at these hazards in all the procedures. But we do not start and tell the people you have to do it. As a moderator, you try, after the hazard identification has been completed, that you look at all the hazards of the minimum hazard list have been considered or not. If not, you consider them, ask the people. And there might be, albeit there is already a standard likelihood and probabilities for the master minimum hazard list given. For a specific location, you can deviate from them. For instance, if you have as a risk bird strike, and for the overall operation, it's a certain likelihood, let's say 10 to the minus, let's say 6, and all of a sudden you have a base or a procedure next to some natural reserve where birds nest. Well, you can reduce that, of course, to maybe 10 to the minus 3. So that is important. These master minimum hazard lists should also be coordinated ideally with a national authority and involve stakeholders. Now we talked about we have to ask the experts, what do you think? And when we did that, I thought, well, yeah, it's valuable, it's priceless, as I said. But I was not believing that in the beginning. I thought, there might be bias. I don't buy that. So we look at here at the safety risk analysis in Nottwil, and we asked, we have this structure, what we have looked in. After all, you see here, traffic experts, data set, what we have, likelihood experts, and looked into the MAC, NMAC likelihood and estimated. What I show you is here, that is the expert's opinion on traffic. Heinz was also here involved. We did that. And we said, okay, the traffic is somewhere here. You see that. Okay, this is where we have to pay attention especially. Or we have to pay attention especially in other parts where we think there is no traffic because we expect it here, and there we don't expect it. Could look at that from this perspective as well. But now, I didn't believe it so really. I said, well, are they right or not? How could we prove that? So what we did we tried to go the extra mile, maybe about 2 miles. And we evaluated the radar data for 1 year. And we took purposely June to June, because we would like to include summer and winter. So to also balance and alleviate seasonal variance and spread. So and then you find here the radar result of the traffic, of course. So what we did now, you remember that? See? Corresponds absolutely. And you could try that also for other examples. Trust your experts. But of course, you need not only 1 or 2, you need a few more experts, and let them discuss openly, free. Don't limit them. This is the reason sometimes why it takes a little bit longer. But as said, if you get this experience of people, pilots, controllers, who are used to that environment, who have done that for 5, 10, 15, or even 20 years, that's really important, and you need to know that. The show must go on. So how does the show go on? We have the safety risk assessment. We have the validation again of the safety risk assessment. You have to see, is it really valid or not after it has been written? And the monitoring and mitigation, monitoring risk and mitigation is also important. You must, sorry to say it that way, you must avoid the single action bias. Having written a safety risk assessment does not prevent you from any incidents or accidents. You have to continuously monitor that and make the necessary adaptations whenever necessary. When you find out something has changed, then you do again the safety risk assessment. If not, it's dangerous. What is that? That was not the presentation, okay. There was one part missing, it doesn't matter. What I can tell you, I do that now verbally, I have 7 more minutes, excellent. I would like to do that on the example of the Challenger catastrophe. You remember Challenger, when Challenger crashed in the 80s. What was the reason of that? The reason, you all know, the booster rocket exploded and the spacecraft burned. Why did it happen? Because the O-rings in the booster rockets have always been considered one of the highest risks. These O-rings have then been modified. They tried to modify, and I said, well, it doesn't work. So if it doesn't work, we just add a second O-ring and things should be fine, and it's really proof. That worked. And with this result, NASA has stopped the companies to develop a new O-ring. It worked, it was fine. Then we come to human factors also in such organization and such a situation. And these times there was a competition between the USSR. Some people even don't know that. Oh, you're old enough, you know the USSR still. And the US. Because our friends from the US wanted to be the first. They tried to advance in space flights, and they said, well, we are the best. We have the shuttle. We can do that. They were really convinced they operate safely, and they do a great job because they have a lot of procedures and everything is in best control. Tons of checklists, and they have all been performed and checked. Then, all of a sudden, to improve the performance, the walls of the booster rockets have been made thinner. So a weight reduction program. That caused again problems with the O-ring, but was not so relevant considered. Then there were budget cuts, and the O-ring issue has been considered as solved because there was not an issue, there was no incident at all. And the quality checks on the supplier have been reduced, not only on the O-ring supplier, on other suppliers as well, because everything was well under control, and people were convinced it simply works. Then again, the risk of the O-ring, why was that an issue? It was temperature sensitive, and low temperatures caused some erosion of the O-ring. And when you look at the photos, 48 hours before takeoff, when the shuttle was on the start ramp, you could see ice in Florida. Yeah, sometimes you have ice in Florida. Unfortunately, that was the case before the launch. And unfortunately, an administrator, not the NASA administrator, an administrative person, has deleted the O-ring issue from the most 10 or 20 most hazardous risks, because it was considered as solved. So because it was deleted, nobody paid attention, was not on a checklist. The result is well known, and if you read the result of the Presidential Accident Investigation Commission, that is being confirmed. A faulty design due also combined with an unacceptable sensitivity to low temperatures in combination with several human factor issues caused that tragedy. Stage 4. We don't want to enter that. And this is the reason why we have to continuously monitor and adapt what we are doing in risk management, and we have to avoid the single action bias. So, having said that, I hope I have not preached here to the choir. If so, I'm happy to listen to your best song, dear choir, or else I'm happy to take your question, and thank you for your kind attention. Thank you very much. I see you don't want to sing, so that's fine. I'm sure you sing very well.
Should I give it a try?
Come on, up to you. Which song?
Thank you, Stefan, for the very nice presentation. I'm calling now on stage David Vigoureux from Riel. On hoisting missions, a safety jump is possible.